Hello everyone, welcome back to Math with Allison. Today we're working in our curve series and we're going to be learning how we can convert between polar coordinates and Cartesian coordinates or rectangular coordinates. So here first I have the polar coordinate system and I also have the Cartesian coordinate system. Question is, how do I convert between the two? It's kind of like, and I'm not going to do it because it gets a little confusing, but it's kind of like you can just overlay the two. So you can see a lot of line action going on there. So I'm just going to have them separate for now, but pretend they're kind of overlaid. So let's go ahead and take a random point. No, I don't like that one. I'm going to take this point right here. What if I wanted to convert that point from a polar coordinate, which we know the coordinate, right? I went out a radius of 3 and I'm at the angle pi over 4. What if I wanted to take that, but I wanted to represent it in terms of x and y? So let's go ahead and I'm just going to move this over here. So let's pretend that we're living in the Cartesian plane. So I also want to duplicate my angle that I'm at. So this way I can just really represent the point. Okay, so here we can see the point is going to be right here. How do I represent this in terms of x and y? Well, guess what we're going to do? We are going to go ahead and draw a right triangle. Yay, everybody loves right triangles. So in our right triangle, we have that the radius is going to be the distance from the origin to the point. And we also have the angle is going to be theta. Now, to convert it to x and y, I have to have an x and y. And I know when I normally plot a point x comma y, I go over a distance of x and I go up a distance of y. So this is going to be our triangle. We can see our little triangle right here. We have the radius, we have our x, we have our y, and we have our theta. So let's go ahead and start by converting from polar to rectangular coordinates. So I want to represent x and y in terms of r and in terms of theta. So let's begin with just x. I know that x over r is equal to cosine of theta, right? I know that x is the adjacent. I know that r is the hypotenuse, right? SOHCAHTOA. So if I were to solve for x to be all by itself, I would just multiply over the radius. So x is equal to r cosine theta. That's all it is. You're going to do the same thing for y. We know that y divided by r is equal to sine of theta, right? Y is the opposite leg, r is the hypotenuse, so SOHCAHTOA. So here I get that y is equal to r sine of theta. And it is indeed that simple. We have, if we're moving from polar coordinates to rectangular coordinates, you just plug in the values. X is equal to r cosine theta, y is equal to r sine theta. Now for rectangular to polar coordinates, you're going to use the equation for a circle. So first you're just going to use right over here that r squared, the radius squared, is equal to x squared plus y squared. So if you're given a point x comma y, you can solve for the radius. You take the square root of x squared plus y squared and you already have the radius, right? Now the theta, let's go ahead and figure out how we got this theta. Theta is equal to the inverse tangent of y over x. So we want to solve for theta, but I only want it to be in terms of x and y. So we know that tangent of theta is equal to opposite over adjacent, and that's literally where it comes from. I'm just going to take the inverse tangent of both sides. Theta is equal to inverse tangent of y over x. So if you're given x and y, you can find the theta by taking the inverse tangent of y over x. You do have to be very careful about what quadrant you're working in because the calculator is going to give you a different answer sometimes. But we're going to go over an actual example of that. So here's our first example. We want to express the point 2, 3 pi over 4 in rectangular coordinates. Let's go ahead and practice graphing it out, right? I'm going to go to 3 pi over 4, which is going to be this angle right here, 3 pi over 4. And I'm going to go out a radius of 2, so I'm going to go 1, 2, which is going to be this point right here. Now I want to find the x and I want to find the y of this point. So let's go ahead and do that. We have that x is equal to r cosine of theta. So we know here the radius is equal to 2 and our theta is equal to 3 pi over 4. So we know what cosine of 3 pi over 4 is. That's going to be negative root 2 over 2, right? Because the x in this case is going to be in the left direction. It's going to be negative. So here we end up with negative root 2. So our x is going to be negative root 2. And let's go on and find our y. Y is equal to r sine of theta. So in this case, r sine of theta, we get 2 sine of 3 pi over 4. In this case, sine of 3 pi over 4 is going to be positive root 2 over 2, right? Because the y is still going up, so the y direction is still positive. So here we end up with the square root of 2. So our point is going to be negative root 2, root 2. It is that simple. It's just probably like maybe the hardest part for you guys is thinking, oh, I have to memorize these things. If you just remember the triangle, you can always whip it out. You know, if you remember theta, r, x, and y. If you forget it, you can always whip out the triangle. But yes, you're right. It might be a bit more memorization. You also have to remember the, trigonometry, which I know is not everyone's favorite. Okay, sorry. Let's express the point 1, negative 1 in polar coordinates. So what we're going to do is we're going to graph it out first. So on our Cartesian plane, I'm going to go over 1 and I'm going to go down 1, which is going to be this point right here. You can already see that it is set up to represent it in polar coordinates. And let's go ahead and calc it out. So we have the r squared is equal to x squared plus y squared, or you could just immediately take the square root, right? So the radius is equal to the square root of x squared plus y squared. So when we plug in x and y, this is going to be 1 squared plus 1 squared, which is equal to the square root of 2. So far in our polar coordinate, this is going to be the square root of 2, which is the radius of this guy right here. Now we want to go ahead and find the angle where this occurs. So let's go ahead and take theta is equal to inverse tangent of y, negative 1, over x, 1. Or, right, this is going to be inverse tangent of negative 1. So the angles that this occurs at is going to be 3 pi over 4, 5 pi over 4, and 7 pi over 4. Right? There's two possibilities where this is true. It's going to be where the sine and cosine have opposite signs, but they're the same value. That's going to occur at all the pi over 4s, but where they have opposite signs. So that's going to be at 3 pi over 4 and 7 pi over 4. So this is where I say we have to be a little careful because we have to choose accordingly. So there are multiple points you could choose. So the first thing is that notice in this quadrant, right, this is going to be 7 pi over 4. So one example that we could choose is pi, or the square root of 2, and then 7 pi over 4. Another option would be if we went out in this opposite direction, this is going to be our 3 pi over 4. We can still choose this angle. So that's going to be 3 pi over 4. But our radius is in the opposite direction. So you could choose negative square root of 2, 3 pi over 4. So either of those options are okay. If you jazz it up even more than that, I'm sure you can find a lot more answers that are still correct. So here I have the little hint for you guys. You have to be careful with the theta. The calculator, especially when we're working with not really nice angles, in this case we have a nice angle, this is going to be 3 pi over 4, blah, blah, blah. If we're not working with a nice angle, the calculator is only going to give you one of those answers. You need to consider where the point is actually located, and you need to add pi accordingly, or you can make the radius negative, or you can do any of those things, right? So let's go ahead and try, this is a very nice example. We're going to give two polar coordinate descriptions of the point 1, 0. So this is a Cartesian point, right? That's going to be this point 1, 0. So sometimes you can do this without even having to actually calc it out. Like I'm not going to bring out my inverse tangent. I'm not going to bring out my x squared plus y squared. I'm just going to think about it logically. I know I'm living on this circle right here with a radius of 1, right? And I know that this theta is going to be 0 or it's going to be 2 pi. So here's one way we can represent 2 points. We have a radius 1 and we have an angle of 0, or a radius 1 and an angle of 2 pi. Or you can do the opposite, right? Instead, what if we talked about the angle of pi? Now, if I went out to pi, I would have to have a negative radius because I would want to shoot backwards in the opposite direction. So here's another example. You could have negative 1 pi. I'm sure you can think of more. Here's our last example. We are given the point negative 3, negative 7, and we want to go ahead and write it in polar coordinates. So this one's going to be a lot more difficult with graphing, right? Let's go ahead and graph out the point. Gosh, that's going to be big. Okay. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. I barely made it. So this is going to be the point all the way down here. Negative 3, negative 7. We're going to have a huge circle, which I'm not going to draw out because you saw how big it is. And we're going to have some angle where this is living. So let's go ahead and use our formulas. So r is equal to the square root of x squared plus y squared. So we get negative 3 squared, which is 9, plus 7 squared, which is 49. So here we get this radius is going to be the square root of 58, which is equal to, here's my calculator. I've had it for so long. It's so cute. Okay, so we're going to do the square root of 58. This is equal to, I'm just going to round to 2 decimal places, so 7.62. So we're going to have a very long radius. This is 7.62. Let's go ahead and find out where the angle that this occurs at. So theta is equal to inverse tangent of y, -7, over x, -3. So you could cancel out right those negatives. So inverse tangent of 7 over 3. I'm going to give it in terms of degrees today, because why not? So for degrees, we're going to take inverse tangent of 7 divided by 3. My calculator gives me 66.80 degrees. So 66.8. If you don't like that, you can do it in terms of radians, right? So let's go ahead and think about that answer, because you can't just trust your calculator and be done. If we were to think of 66.8 degrees, that's going to be like right here, 66.8 degrees. That is not where our actual point is living. We're living in the opposite quadrant, right? So one way that you could correct this is you could say, okay, let's take that angle, so 66.8 degrees, and let's just go ahead and make the radius negative. So we could do -7.62, right? And that could be our point. Another way you could do it is you can add 180 degrees, right? I'm not going to just stop at 66.8. I want to go all the way around. So that means I have to add 180. So when we do that, we end up with a number 246.8 degrees, or whatever that is in radians. If you're working in radians, you would just add pi. So 3.14-ish. So another point that we could give is our positive radius, so 7.62, and then our angle that we're actually living at, so 246.8 degrees. So either of those answers would be totally correct. It's just up to you. You just have to remember to take a moment, pause, graph it out if you need it, and think about if that angle is actually true or not. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.